All right, our final lesson for this unit is putting it all together and solving multi-step problems. Okay, so working with formulas and solving problems that are going to have, like in this scenario from this lesson, like an A, B, C, and D question. So let's dive right in and let's look at a scenario. William has decided to paint his living room. The length of the living room is 9 meters, the width is 6, and the height for the floor to the ceiling is 3 meters. Determine the total surface area that William will paint if he used 2 coats of paint. So this is a excellent question that pertains to real life if you were doing any sort of painting. So let's break this down. We have to determine the total surface area that William will paint if he uses 2 coats. Okay, so we need to determine um, how many walls here are being painted or what are the size of the walls and then the number of those walls that are there. Um, we don't necessarily need to paint the ceiling. Okay, let's leave the ceiling as is and let's only paint the side walls. Okay, so the length of the living room is 9 meters. So let me just draw the room here. Let's call that 9. Let's call this 6 meters. Okay, and then the height for the floor to the ceiling is 3 meters. So we are going to have two 9-meter walls. Okay, so we're going to have two walls that are, I'm going to draw their heights, 9 meters by 3-meter height. Okay, don't forget that that's our height from floor to ceiling. There's going to be times 2 of these. And then there's going to be two 6-meter by 3-meter walls. So there'll be 2 of those as well. So quite simply, to figure out this total surface area, we just have to figure out the area of each of these shapes, multiply them by their respective quantities, and and then add them all together, and we'll have our total surface area. So let's call this shape um, area 1. Let's call this area 2. So our total surface area is going to be equal to 2 times area 1, because there's 2 walls, plus 2 times area 2. Area 1, I know that the area of a rectangle is length times width. So 2 times the length times the width of our first area is 3 times 9, plus 2 times 3 times 6. Okay, that's just length times width for each of our rectangular shapes there, our walls. So we get 54 plus 36. Okay, so again, we're not going to count the ceiling. The question doesn't say anything about counting the ceiling. Typically, if you were to paint your house, you'd leave your ceiling white and then you'd paint the walls any color you prefer. Okay, so here we go. 54 plus 36 is 90 meters squared. But it says determine the total surface area that William will paint if he used 2 coats of paint. So for 2 coats, what are we going to do to our value of 90? Okay, take our 90 meters squared, times it by 2 coats, and we get a total of 180 meters squared that we essentially need to paint here. That's our total surface area, 180 meters squared. Again, that's not including the roof. How many 4-liter cans of paint should William purchase if 1 liter of paint will cover approximately 12 meters squared? So when you go out and you buy paint, a can of paint, which is typically a liter, should tell you how much it can cover. So in this case, a liter of paint can cover 12 meters squared. Okay. Or sorry, a 4-liter can can cover, let's reread that. How many 4-liter cans of paint should William purchase if 1 liter of paint will cover approximately 12 meters squared? So that means a 4-liter can Okay, so if 1 liter covers 12 meters squared, a 4 liter can should cover 4 times that. Okay, so it should cover 12 times 4, which is 48 meters squared. Okay, so if a 4 liter can covers 48 meters squared, we need a total of 180 meters squared worth of paint. So how are we going to calculate how many cans we'll need? Well, we need to determine, okay, so this is where our problem solving comes in. We need to determine the number, and you wouldn't normally write this, I'm just writing this as I'm thinking through this. Determine the number of times 48 divides into or fits into 180. Okay, so let's determine how many times, the number of times 48 goes into 180, and that's going to give us the number of cans that we need. So number of cans is equal to 180 meters squared divided by 48 meters squared. Pull out your calculator. 180 divided by 48 is a total of 3.75 cans. Now we know that we're not going to go out to the store and buy 3.75 cans. It's always good to buy a little bit more than you think you need anyways. So let's round up to 4 cans altogether. Okay, so 4 cans is how much paint we'll need to do 2 coats of this room. Next question. William has researched on the internet and has found a suitable paint that will cost $30 for a 4-liter can before tax. $30 for a 4-liter can before tax. Determine the total cost before taxes to paint his living room. Pretty straightforward. If we need 4 cans, okay, and each can costs $30, I'd say this is a pretty straightforward question. To figure out your total cost, simply multiply number of cans times cost per can, which is 4 times 30, which is $120 worth of paint before tax. And of course, if we were to calculate tax there, just multiply it by 1.13. Okay? 1.13. By the way, before I move on to the next question, if you struggle with determining this question above here, that you had to do 180 divided by 48, another method you can use when solving these types of, what they really are proportions, is you can do the following. Okay, they've given you a proportion here. They've told you that 1 liter covers 12 meters squared. So what you can do is set up exactly that, set up a proportion. 1 liter covers 12 meters squared, and that should equal to, well, we don't know how many liters we need, and we need to cover 180 meters squared, right? We got to cover 180 meters squared. So we don't know how many liters that's going to take. That's what we want to solve for. Let's call that X. Okay. And what have I told you before as a method of solving a proportion equal to another proportion when we have an unknown is you can cross multiply. So we have 12 times X, or 12X, is equal to 180. x is equal to, we need a total of 15 liters, right? Now, that doesn't fully answer our question because our question is how many cans of paint? So, although this is a good way, I mean, you can see that now we have to do a second step, although we kind of did two steps in my first method. Um, but we did it really quickly, kind of mentally, where we converted the fact that um, this was for 1 liter of paint, but we can buy 4 liter cans. So we simply multiplied 12 times 4 here already. So we've already done this. But what you want to do here is if you have 4 liter cans, right? And you need 15 liters, you'll clearly need 4 times 4 or 4 cans there to cover the 15 liters, right? 4 cans will take you to 16 liters, which is your 4 times 4. Okay, but that's just another method that you can handle this. And actually, we could have set up even another proportion to solve that second part. Okay, so we could have actually set up, once again, another proportion. So this is just a separate little thing that you can do. Keep that in the back of your mind of setting up these proportions when, for a lot of these questions that you'll see in today's lesson and in today's homework. All right, what are some factors that William should consider before he makes his final decision on the amount of paint that he purchases? So, what are some factors that William should consider, okay, before he makes his final decision on the amount of paint that he purchases? So, if he's got to paint 2 coats, anybody who's done any sort of painting knows that sometimes the quality of paint really is a determining factor in how much paint you need, right? A cheaper quality paint, you'll need to do more coats. So you may go in thinking you just need to do 2 coats, but depending on your quality of paint, you might have to do more, maybe even less than 2 coats, depending on that quality. Okay, so that's one thing that you'll need to consider for sure. Something else that you might need to consider, anybody who's done any painting, is the current color on the wall. So a deeper color will be harder to cover, right? So if you currently have like a deep blue color on your walls and you wanted to paint your walls a very light color, you may need more than 2 coats in order to cover that deep layer or that deep colored layer. Okay, so that is something that you would certainly need to consider, and that's the current color that is on the wall and how easy you think it might be to cover. Obviously, white is the easiest. Anything slightly off white is the easiest to cover, but anything darker is going to be a little bit more challenging, and you may need more coats. Okay, and if I could think of anything else in terms of before you go buy this paint, what you'll want to do is decide whether you want a gloss paint, so more of a shine, or if you want a matte, which is more of a flat color paint that doesn't have any shine. So that's another thing that you might want to consider. Okay, so I think that's enough for this lesson and just going through the types of problems that you're going to be solving. A lot of these are common sense. A lot of them are just problem solving questions, but often you will need to employ or deploy this method here of setting up proportions and cross multiplying to solve for unknowns. And notice when I set up the proportions, I line up my units of meters squared, for example, in this case, and liters up here. So as long as your units are lined up horizontally, then you're doing everything correctly. If I put liters here and I placed liters down here, or vice versa, that would be incorrect. You will not be setting up a proper proportion. To set up a proper proportion, you have to have the same units across horizontally. Okay? So remember, practice how to do this method. It'll come in handy, I promise, as you're doing today's homework.